Hello world, welcome back to another TryHackMe challenge video. In this video, we'll be walking through the Investigating Windows 2.0 room. Let's get into it. Okay, to start us off, I have the actual challenge VM open over here on the right. And if we scroll down, we'll see where we need to begin with task 1. Due to us already using the room's virtual machine, we don't need to do all this login stuff. And we can jump into answering the first question. What registry key contains the same command that is executed within a scheduled task? Okay, so for this part, we're going to go to the computer management app. Then we're going to go to task scheduler. Drop that down and look at the task scheduler library. And we're looking for a task that appears to be suspicious. We're going to take a look at this game over task. And if we go look at the actions, we can see that from the temp directory in the C drive, a mem.exe is being executed. And then it has a parameter of sec url sa ::logon passwords. So we're going to want to find the registry key that contains this command. So now we're going to open up regedit. And then what we're going to do is we're going to select computer up here, and let's go ahead and maximize this. And we're going to do a control F, and we're going to find the set URL SA string that we saw in the scheduled task. Let's go ahead and scoot this over so we can see the right pane better. We'll find this user init npr logon script. And if we scroll over here, we can actually see the data value that this key is assigned to. And it appears that it is the same mem.exe command that we saw previously. And as you can see, it's being launched through the scheduled task here, probably at different intervals. If we go and examine the scheduled task, we'll be able to see that. But for our intensive purposes, the answer to our first question here is user init npr logon script. So let's see if we can copy that. Remember, we can copy out of the VM, but we can't copy into the VM. Now we need the rest of the key, which we can see right down here in the bottom left-hand corner. We can ignore the computer portion. We need hkey _ current _ user. But really what we need is just the abbreviated form of it. / environment / user init npr logon script, like so. And there we go. Next question reads, what analysis tool will immediately close if or when you attempt to launch it? Well, if we go to our desktop, let's go ahead and just minimize this in case we need it later, and that. We'll see that there's this tools directory. And what we're interested in is actually the sysinternal suite right here. Now the two big kind of process monitoring scripts, which, you know, if you launch a scheduled task with an executable, it's going to appear as a process at some point in the task manager. So the two most prominent ones we're going to be taking a look at are procmon and proc explorer, or proc exp. And since this is a 64-bit machine, we'll be dealing with the 64-bit versions of them. So if we launch procmon, we'll notice that it opened, so this isn't the right one. We'll minimize that because we'll need it later. Let's try opening proc explorer. Ah, see, that didn't even open. So that appears to be our answer for this question. And before we continue, I'm gonna go ahead and go to control panel. And we're gonna go to environment variables, edit system environment variables. And this will be useful for later on when we need it. I'm gonna go ahead and get it out of the way now. But we're gonna modify the path here. We're gonna do a new key. And then we're gonna do the path to the sysinternal suite here. Paste that in. Okay. And then one more thing we want to do is File Explorer Options. Right here. And then we're going to want to click View and then unhide extensions for known file types. That way we can see the extensions in the File Explorer. So if we reopen our file explorer here, we'll see all the extensions for all these files in here and for any other files on the system. Moving on to the next question after that little detour we took. What is the full WQL query associated with this script? Now, I forgot to mention that this room is kind of all over the place, so it's going to be kind of hard to follow those questions and exactly where it's talking about. But that's fine, because that's what I'm here to kind of help with, is kind of streamline the process and the flow of these questions. So for this one, we're going to go look at the Loki logs, and the Loki is just another kind of system analysis tool for malware and stuff. And they've already got some logs here for us to look at, so we're going to take a look at the latest one. And we're going to do a search for a WQL query. Now, for those of you who don't know, WQL is a WMI query language, which is basically like SQL but for WMI, which is the Windows Management Instrumentation toolset. So let's look for a common query string, which would be select star, like so. And sure enough, we found some queries right here in our Loki logs. Now, what we're looking for specifically is the query string for the proc.exp64 executable. So when it says script, what it really meant is we need to look for the executable. And sure enough, right underneath the first match that our find came back with, we see our WQL string query for proc.exp64. So we'll copy that and paste that in and submit it. Now it's asking, what is the script language? Well, if we go back to our task scheduler, we'll notice that the mem.exe file is being executed from c:/temp, if you remember from earlier. So we'll go back to File Explorer, and we'll actually just open up a new File Explorer. And we'll go to that ctemp. And we'll actually see that there's a very suspicious script in here called wmi_backdoor.ps1. So let's go ahead and take a look at that in PowerShell ISE, which is the native development environment for PowerShell. And let's just take a look and see what we can find in here. Well, this is quite clearly not PowerShell, as indicated kind of by how the function structure is. This is actually going to be VB script. And if you actually do a Control F for VB in here, you'll eventually find a variable that says VB script. So if that isn't telling, then I don't know what is. So our answer will be VB script for this question. Our next question asks, what is the name of the other script? Well, you'll notice if we go back to that ctemp directory that there's other scripts in here, but these aren't what we want. Let's go back to the Loki logs. And let's just take a little further look around where our WQL query we were looking at earlier was, and see if we can't find anything else interesting here. If we actually look right underneath where our WQL query was, we'll see that there's this script event happening with the name launch beaconing backdoor. Okay, that's very interesting. Let's see if that name shows up in that script we were looking at. And sure enough, it does. If we look here, we can see that there's a condition saying if the action name, whatever the action name is, exists. If we scroll up, we can actually see where the action name is being called. It actually ends up being a parameter passed into the new WMI backdoor action function. Let's go back down to where we were just at, though. So it sets the name equal to the action name. So whatever getting passed in, that'll be the script name. Else, it'll default to the script name of launch beaconing backdoor. So launch beaconing backdoor appears to be the backup script in case the first script fails. So we'll go ahead and copy that out as our next answer and submit that. What is the name of the software company visible within the script? Now that would probably be listed out in some kind of comments. So if we just keep scrolling around and look for, stuff like this, where it's big blocks of text with what looks to be comments at the top, we can actually see a company name listed right here, Motobit Software. Let's type that in, as that should be our next answer. Our next question reads, what two websites are associated with this software company? Well, if we look in that same comment, we'll see two URLs specifically, motobit.com and motobit.cz. So those will be our next two answers for this question. Now our next question asks, search online for the name of the script from question 5 and one of the websites from the previous answer. What attack script comes up in your search? Okay, so question 5 was 1, 2, 3, 4, 5. Okay, so that's the launch beginning backdoor. So we'll go ahead and copy that. We'll put that into a Google search along with one of the URLs. We'll go with the CZ one since that looks more suspicious. And we'll see we get the WMI backdoor.ps1 script that we were just looking at to get the previous few questions. So it all comes full circle. So this answer will be WMI backdoor.ps1. Now, what is the location of this file within the local machine? Well, we know that because we just found it. It's in C:temp. So that's gonna be our answer. Which processes open and close very quickly every few minutes? Well, to figure that out, we just go back to our task scheduler and we'll see that two of these tasks here are scheduled, one for 5 minutes and one for 2 minutes. So that'll be the false update 22, which I'm guessing that meant to say flash update, and the game over, which we were looking at for previous questions. However, it's asking for which two processes, and those are just the names of the scheduled tasks. So the actual processes are what's inside the actions, which is PowerShell and mem.exe, respectively. So those will be our two answers. What is the parent process for these two processes? Remember how we opened up Procmon earlier? Well, that's what we're going to be looking at to determine what the parent process for these two processes is. To do this, we're going to click the filter. And we're going to filter by the process name. Now, there may be other results for PowerShell.exe, so let's go with the more unique name here, which is mem.exe. Then we're going to add that as a filter. Then we're going to click Apply. Okay. Now, to discover what the parent process is, we can just select one of the entries for mem.exe and click Properties. You can also just hover over it, and it should just give you that information as well. But regardless, let's take a look at the event properties window we have here. And we can see that our parent PID is 444. Knowing that information, we can go back to our filter and we'll add a new filter for the PID. And we'll say the PID is 444, like so. And we'll add that and we'll uncheck our mem.exe one. And we'll see that our PID's matching process name is svc host.exe, which is a Windows native host executable. But in this case, I bet it's just a malicious executable masquerading as the actual svc host executable. So the answer to this question ended up being svc host.exe. What is the first operation for the first of the two processes? So for this one, we're going to uncheck the PID again and recheck our mem.exe. And we'll notice that the first operation is this process start. And that will be our answer. Inspect the properties for the first occurrence of this process. In the Event tab, what are the 4 pieces of information displayed? Okay, so we'll just close out of this real quick and we'll just go back to that properties window we had open previously. And we can see that the 4 pieces of information displayed, which are down here in this details panel here, are the parent PID, the command line, the current directory, and the environment. As we can see here, the parent PID is, of course, the svc host.exe. Command line, that's what's actually being executed, which you saw back in the actual task scheduler itself. Current directory is wherever this is being executed from. And then the environment are just all the environment variables at the time of this process's execution. So let's go ahead and type all those in. and submit that. All right, inspect the disk operations. What is the name of the unusual process? So we're going to go to a different analysis tool for this one. Inside of our tools folder back here, we'll have a process hacker 2, which kind of serves as a mimic for the process explorer from earlier, but since we can't open that one, we have to use an alternative. All right, you'll notice a tab up here called disk, and we're gonna let this run for a little bit just to see what it comes back with. So while that's going, we'll go ahead and move on to the next question, and we'll see that it says run Loki, inspect the output. What is the name of the module after init? Well, fortunately, since Loki was already ran for us, we can just inspect the logs that were already there for us in the challenge. So once again, I'll go back to actually opening up that log we were just in. I have 2 of these open, don't need both of those. And we're gonna do a Control F for init. And actually we wanna go up. So we'll see that when Loki launches, it starts with the init module. And then there's a little PC module being run here, but that's not what we're interested in. We're interested in the module that happens after all these inits, which is the WMI scan module. And that's going to be our answer for this question. Now, let's go back to the process hacker here. And let's scroll down and see if we can't find any kind of suspicious processes that are being executed. Scrolling down, you might find some processes with no process name. Or rather, they're just called no process. Either way, it is very suspicious to have processes without any identity behind them. That being the case, this is going to be the answer for this question, because having no process name, that is a red flag because you don't know what's actually being executed there. All right, moving on to the next question following the WMI scan question. Now that we've kind of backtracked a little bit here to answer that question. Regarding the second warning, what is the name of the event filter? So we're gonna go back to our Loki logs here. We can take a look back at the WMI scan messages here, and it's asking for the second warning, so we wanna look at the second WMI scan message here. If we scroll over, we'll see that the name of the event filter, which is designated by this class header here, is process start trigger. And that should be the answer for our question. For the fourth warning, what is the class name? Okay, so going 2 more warnings down here. As you can see, this one right here will be our fourth warning. We're gonna look for the class name, and the class name is filter to consumer binding. So that should be our answer for this next one. What binary alert has the following 4D5A9 blah 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 as first bytes? So for this one, we can just do a Control F for the first few bytes of that, what appears to be like a hash value or a hexadecimal value. And we'll just do that, and then we'll do find next. Now you're gonna notice that there's a few of these with that same first bytes hexadecimal string there. But we're looking for the first entry, which will be this mbtscan.exe executable file. So let's go ahead and submit that. According to the results, what is the description listed for reason 1? So for this one, we'll just be looking back at our mbtscan.exe entry here in the logs, and we'll just be scrolling to the right for this one to find reason 1. Right here. And what we're interested in reason 1 is not this first part right here. We want to look for the description, which is right here, known bad / dual use classics. And that should be our answer for this next question. Which binary is marked as APT cloaked? Well, if you look down at the next line, you'll notice that there's an APT cloaked kind of string in this match header right here, which means that this is going to be the entry that we want to look at. And the corresponding binary is p.exe. What are the matches, string 1 and string 2? So going back to the right, remember it had a match there. And what we're looking for is the 2 strings that it matched to, which are right here. The first string match ends up being psexe svc.exe, and the second string match ends up being sysinternals psexec. Now, doesn't that look familiar? So we'll grab these 2 strings as our answer. And submit that. Okay, which binary alert is associated with something windows.dmp found in c:/temp? Well, if we scroll back over where we were just at, we will see that a couple lines down, there's this scanning memory dump file something windows.dmp. So the binary alert that's associated with that would be the one that's right above it, because this binary alert is providing info for the previous binary warning. So our binary that's associated with this DMP file is this sch tasks tac backdoor.ps1 file. It's just kind of funny how those processes are scheduled and they're getting in the way. I could disable them, but I want to keep them running just in case we need to do something with them running later. So we'll copy that name, paste that in, and submit that. Okay, which binary is encrypted that is similar to a Trojan? Well, if we go down to the next line, which is kind of the last file that you kind of see in this sequence here of binary alerts, you're going to notice it says xcmd.exe. Now, what is a Trojan? A Trojan kind of masquerades as a legitimate process and then takes over the host device or something in the host. So xcmd is probably mimicking cmd.exe, which is what you use to connect to the terminal in Windows. So if we scroll over, we can confirm these suspicions because we'll find that, first off, it says detects an executable encrypted, right? Keyword there, encrypted, with a 4-byte XOR, also used for Deruzbi Trojan. Well, there you have it. So xcmd, as suspected, is a Trojan, or similar to one anyways. So that'll be our answer for this next question. Our next question reads, there's a binary that can masquerade itself as a legitimate core Windows process / image. What is the full path of this binary? Well, remember when we found SVC host earlier in Procmon? Well, SVC host is a legitimate core Windows process. So let's look in the file for SVC host and see if we can't find anything that shows us a different path from where it would normally be stored in, which is System32 usually. Sure enough, our first find result here shows us an svc host.exe file located in C users public. So that is going to be our answer, and before I copy that over, we can actually confirm that to be the case by, let's just go ahead and open ourselves up another file explorer and actually navigate to that C users public directory. And sure enough, we can see our SVC host in here. So in confirming that, we can type that in as our full path and submit it. What is the full path location for the legitimate version? Well, like I said before, it's a core process of Windows, so it's going to be in C Windows System32. We can find that very easily by going to File Explorer, and we'll just go to C Windows. This is where all the native core Windows processes and executables are stored. So come in here, and instead of scrolling down, we'll just search for SVC host. And sure enough, there you have it. It's in this folder. So we'll just copy, I'll go back. We'll just copy that path. Paste it in and submit that. All right, what is the description listed for reason 1? So we're gonna go back to our Loki logs here, and again, it gets kind of confusing because they don't tell you specifically which entry we're gonna be looking at, so you just kind of have to follow from the previous questions and assume that this is the one we're gonna be looking at. So we're gonna scroll to the right and look for our reason 1 for SVC host here. There's reason 1, and the description says stuff running where it normally shouldn't. And that will be our answer for that question. Now then, there is a file in the same folder location that is labeled as a hack tool. What is the name of the file? So going back to that public directory that had our SVC host in it, our malicious one anyways, you'll see that there's our malicious procdump64.exe as well, but then there's also a random JavaScript script in here. That's kind of weird. So let's take a look and see what that looks like. And lo and behold, we have a lot of just random base64 text in here, which is a good indicator that this is most certainly some kind of malware, or it's trying to inject some kind of malware. So we just need the name of the file for this, and we'll just use that as our answer. Now, what is the name of the Yara rule match? Going back to our Loki logs, we're now going to be looking for the name of the Yara rule match for that JavaScript file that we found previously. All we need to do is do a Control F for something with .js, and sure enough, we'll find a Loki entry for that malicious script. If we scroll to the right, we'll eventually stumble upon our Yara rule match, which ends up being Cactus Torch in all caps. Moving on, which binary didn't show in the Loki results? Well, you can do a Control F for pretty much all the executables and scripts we ran through here, and I'm not going to do that for you, but basically the answer is mem.exe. That doesn't show up anywhere inside of the Loki logs at all. So that will be our answer, and our following questions will also have to do with this fact as well, because we want to be able to trigger alerts for this executable, otherwise it can just run rampant on the machine without us knowing about it. So let's go ahead and submit that and move on to our next question, which appears to be the final question, and that is, complete the Yara rule file located within the tools folder on the desktop. What are the 3 strings to complete the rule in order to detect the binary Loki didn't hit on? So for this one, we're going to go back to our tools directory, and we're going to go into our Yara directory here. And this test.yara is what we're interested in, so let's go ahead and open that up. And we can see here that there are 3 string rules here. So we pretty much need to fill in the blanks here where there's question marks. How can we easily go about doing that? Well, typically Yara rules are looking for kind of strings that exist and are unique to the executable or whatever file that's being examined or being quarantined. So all we need to do is kind of look for a similar format within the executable of interest and determine the strings based off that. We can do that very easily by going to our temp directory where the mem.exe file exists in. And remember how we changed the environment variables earlier? Well, now we can use strings from the sysinternal suite freely without having to actually reference the full path to it. So we'll go ahead and navigate to that ctemp, clear the screen, and we're going to go ahead and kind of bring this down here so we can see the question marks. Now we can use strings on mem.exe, and then we're going to pipe that into findstr, which is kind of Windows version of grep to search for string patterns, and it uses regex by default, so we can go ahead and start doing that. Let's look for string 1. We have question mark, dot, question mark, 1. So we don't know what the question marks are, so we'll just represent those by actual dots, which stand for any character, any single character. And then we'll put in a real dot, and we can put in a real dot by just escaping it. And then we'll put 2 more any characters in, and then a 1. And we find out that our first string ends up being mk.ps1. So we'll go ahead and type that result in here. Now we need to do string 2. So same concept, anywhere there's a question mark, we're gonna just put a dot since we don't know what it is. So we'll do dot dot backslash dot dot x dot. And that comes back with mk.exe, which will be our next answer. It's pretty obvious that anything else that comes up won't be that because they don't follow the exact kind of format that we see here. And finally for string 3, back that up and we'll do v dot backslash dot dot backslash dot 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 7. And there we have our final string. Let's go ahead and submit those strings. And there we go, we finished the room. So, if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comment section down below. This is Almond Milk. Thanks for watching. Goodbye, world.